So we need to create two equations to represent this situation. A lot of times the people ask me, how do we know whether it's one equation or two equations? And the basic idea that I can tell you is this: if they're asking you for two different things, then you need two different variables in your equations. If it's, and right here in example one, how many of each animal are there? Where there's ducks and horses, there's two different things that we need. So that means we need to build two different equations. But before we do all that, unpack that problem in a way that lets you see the information. Don't just sit there and try to process it all in your head. When you start writing it on your paper, it's going to let your brain kind of synthesize what's important, and it's going to let you write it down in ways where it's kind of close and saying, well, this is related to that, so let me group these two things together. So let's go through and do that. There are 19 animals in the barn, so we'll write down 19 animals. Some are ducks and some are horses. So these 19 animals, they're made up of ducks and horses. So that's great. I also know that there's 64 legs in all, so I'll write down 64 legs total. If I add up all the legs of ducks and all the legs of horses, it's 64. How many for each animal? Just to make sure I don't make a mistake about what my variables mean, I'm going to use H will equal the number of horses and D will equal the number of ducks. And now I can actually come through and start putting it together. So it says there's 19 animals and it's made up of ducks and horses. That's just like begging to be made into an equation. If I add up all ducks and all horses, it'll equal a total of 19. Now, I've circled this to show that all of this, I'd kind of put it close together and it created this equation. I've not touched the 64 legs total. So we need to come back and make the second equation, because right now I can't know exactly how many ducks and exactly how many horses. I just have scenarios where it could be like 0 ducks and 19 horses, or 1 duck and 18 horses. I've got all of those, but I need another equation so I could solve the system of equations and know exactly how many ducks and how many horses together to equal 64 legs. Well, it's a total, and usually we can put a total over here all by itself when we're using this standard form equation. I know that each duck has 2 legs, and if I multiplied the number of ducks by 2, I know how many legs of duck we have. So if I had 10 ducks, we'd have 20 legs. Make sense? At the same time, we have 4 legs for each horse, so we can do this: 2D plus 4H. And now we just go and solve. Unfortunately, it's not set up for elimination to go straight into it, so we're going to have to change it slightly. I know that I can make this into a negative 2D by multiplying it by negative 2, and so we'll multiply the whole equation by negative 2 as a result. Now we're set up to add the two equations together. The D's are eliminated. That's why we got the elimination method. Here's 2H, and here is 26. Divide both sides by 2, and we know we have 13 horses. Now, 13 plus what, or 13 plus how many ducks would get 19 animals? It'd be 6. So we substituted that back into the equation, and we know that we have 6 ducks. Let's take a look at another example that's a little bit different, but similar. Basically, it deals with a field trip. We've got 177 students going on a field trip. They take 6 vehicles with them, so let's write that down. We've got 177 students total. They took 6 vehicles. Some are cars, some are buses. So here's the cars and buses. We know that together, if we added the cars and buses together, it'd be 6. And we've got to find out the cars, how many cars, and how many buses they took. And they give us this last piece of information. Each car holds 4 students. So there's 4 students, and each bus holds 55 students. There's 55 students. I'm going to put this in parentheses just that way I know it's kind of related, but I might have to look at it in a different way. Let's go ahead and define our variables. C will represent the number of cars, and B will represent the number of buses. If I combine the cars and buses together, we should get 6. So C plus B equals 6. And that took care of this information. And see, that's the thing that I like about kind of unpacking it, is that we've used all of this. We've not used 177, 4, or 55. And we're going to use C and B again, most likely. So 4 students for each car. That's kind of like the legs and number of animals, 4C, plus 55B, because that's 55 students for each bus. And we don't know how many buses, we don't know how many cars, but we do know total number of students. And look at that, students, students, and students. It kind of groups itself together. It might be better to actually move the 177 down here so you can see that even better. Now, we can go through and solve. We can multiply this by -4, and that will get us -4C minus 4B minus -24. There we go. The C's are going to be eliminated. We have 51B right here. 153, divide both by 51, and we know we have 3 buses. So we have 3 buses, and if we've got 3 buses, we've got to have 3 cars to equal a total of 6 vehicles. So we've got those 2 problems done. Let's take a look at a different type of an example that could possibly cause a little bit of an issue here. Chelsea's Custom Kitchen Supplies sells handmade forks and spoons. It costs $2 to buy the supplies to make a fork and $1 to buy the supplies to make a spoon. So I'm going to leave that in yellow. The store sells, so this is different than cost, it sells the fork for $6 and spoons for $5. Last April, Chelsea's Custom Kitchen Supplies spent $24 on materials for forks and spoons. So that's kind of like spending. Spending and cost is together. So let's go ahead and say they spent $24 on forks and spoons. They sold, well, sold correlates to the sales. They sold the finished products for a total of $100. How many forks and how many spoons did they make last April? Because this is so different, you just need to kind of take your time and unpack the information. So let's see, we've got costs, okay. Now, let's make that a little bit bigger there. Cost. There we go. It cost $2 for a fork. That'd be 1 fork, and it cost $1 for a spoon. Okay, that's in yellow. And then do you see they spent a total of $24 on material? So that's how much cost for each fork and each spoon, but it was $24 cost total. Okay, so that's 3 different pieces of information. Then we can come over here and we can start taking a look at the sold or sell. Okay, let's see, $6 for forks. $5 for spoons, and they sold the finished products for a total of $100. So it's $100 total. Now that's all the information that they've given us, and we basically just want to know, you know, how many spoons, how many forks did they sell? And there's all sorts of different combinations that we can get, but there's only one that's going to account for the cost and the total profit and everything else. Obviously, fork is going to equal the number of forks, and S is going to equal the number of spoons. Okay, that'll help us keep it straight there. Let's make that a little smaller to fit that in. Let's take a look at this right here for cost. $2 for a fork, $1 for a spoon, $24 total of cost. So that tells me I could write it like this: $2 for every fork, so 2 times the number of forks, plus $1 for every spoon equals $24. Not too bad, huh? And this unpacking kind of made it all together, and because we took time to see how these two, the 2 yellows are related, that made it into one equation. And now we can do the exact same thing for the sold category. $6 for a fork plus $5 for a spoon is going to be $100. So I'll drag this over here. And we've got our 2 equations. We can go solve. I'm just going to multiply it by -3. Here we go. multiply this by -3, and we get negative 6f minus 3s equals, let's see, it'd be -72. My f's are eliminated. I have 2s remaining, and I have 28 over here. Divide both sides by that, and I have 14 spoons. So I have 14 spoons ready. And we can plug that into any of the equations. So 2f plus the 14 equals 24. Minus 14 from both sides. We get 2f equals 10. We've got f equals 5, so we have 5 forks. We've got two other examples that are they're different. That's the reason I'm wanting to go through and make sure that we take a little bit of time to look at them. So here, I'm just going to unpack the problem for us very quickly. $660 total. Each math book is $80. Each science book is $60. And I also know that he bought a total of 9 books. So let's use M for the number of math books, S for the number of science books. And now we can just start putting them together. The first thing that I see is that if I added up all the math books and science books together, I'd have 9 total books. So let's just do M plus S equals 9. And let's kind of mark this off here. I've got 9 different books, and we use the M and S there to create those 9 books. But then we've got cost. This is money, and that's money. This is a total. So I can put 660 right there. That's how much it costs. I know each math book cost $80. I don't know how many math books, but I know each one's 80. So 80 times the number of math books plus 60 times the number of science books. There's our equation. We just go through and we multiply by whatever we need to. I can multiply it by a -80. I can multiply it by a -60. I kind of like the -60 because it's a little bit less. -60 times M is -60M. -60 times S is -60S. And -60 times 9 is -540. Add them together. Our S's are eliminated. We have 20M left over. 660 minus 540, or 660 plus 540 is 120. We have 6 math books. Plug that in. If you've got 6 math books, you need 3 science books. So 3 science, 6 math. And we're done. Very last example. I like this one because it's just a little different than what comes up from the other 4. You've got a printing company. There's 2 kinds of printing presses, Model A and Model B. So let's get that down. Now, Model A can print 40 books a day, and Model B can print 55 books a day. So far, I don't even know where I'm going with this. The company owns 6 total printing presses. So let me type in 6 total printing presses. And this allows them to print 300 books a day. So, okay, so we can get 300 books total per day. How many of each type of press do they have? So how many Model A and how many Model B? Now, the great thing is because I've unpacked all the information, and in fact, I even know what I need to solve. I need to solve for A and B. I don't have to look at this again, not unless I think I made a mistake. So let's just kind of take a look at all of our pieces of information, and let's just gently tread our way through and see what we can make of all this. I have 2 types of presses. I also have 6 total presses. So if I said A plus B, the number of type A's and the number of type B's, it should equal 6 total presses. So there's my first equation. So, I've used these 2 pieces of information here. And then, strangely enough, I see I've got 40 books, 55 books. See how it's all books, and then 300 books? Well, let's see what we can do with that. 40 books for each Model A, 55 books for each Model B. Well, I could just write it as 40A plus 55B would equal how many books in a day? 300. So that's our equation right there. And it's not too hard to kind of space it out to make everything line up, even if the numbers are vastly different. There we go. Now we just have to go and solve. And when you're dealing with one equation that's so much bigger than the other, you're just trying to match that smaller one up to it. So I can multiply it by negative 40 or negative 55. Negative 40 will be less work, so that's what I vote for. That would be negative 40a minus 40b equals negative 240. The a's are eliminated. I have 15b left over, and I have 60 right here. Divide both by 15. I have 4 of the Model B printing presses. Well, if I have 4 Model B presses, and sorry for the poor writing, then I have to have 2 Model A presses. And it also makes the second equation true for getting 300 books a day.